Hello, Workplace Math 10 students. Today we're going to be looking at some trigonometry problems that relate to angle of elevation and angle of depression. So let's take a look at what this looks like. So the assignment that you're going to be working on, you will find in Google Classroom, but also in Mathletics, and it's called elevation and depression. So basically this is the last of the assignments that we'll be doing for this trigonometry unit, and then we'll be working on our test after that. So let's get started. So when we talk about elevation and depression, what we're actually talking about are two terms, one being called the angle of depression. And so if you see in here, there is a term called the angle of depression. And basically what that means is it's an angle formed by the line of sight and the horizontal plane for an object below the horizontal. So in other words, this is the horizontal plane and the angle is being formed below that. So therefore it's called an angle of depression. And I'll just scroll down here and show you an example of an angle of elevation. So this angle of elevation is the same idea, but this angle is being formed above the horizontal line. So therefore it's called an angle of elevation. And so let's take a look at how we would go to solve these. So the very first one here, the question reads the angle of depression. So this angle of depression from the balloon to Ed is 38 degrees. So therefore, basically from this balloon to Ed, which is this shape down here, is 38 degrees. And the altitude of the balloon is 55 meters. So what is the horizontal distance between the balloon and Ed? Now we have a nice picture here, and really whatever it's said here in this write-up is really not that important to us so much as we need to understand what we're looking at in relation to triangle. So just like always, what we have here is we have, this is the hypotenuse, this is the opposite, this 55, and then what we don't know is the adjacent. And so the two actual side lengths that we're dealing with that we want to know are the opposite, which we know, and the adjacent, which we don't know. So because it's opposite and adjacent, what we're dealing with here is we're dealing with the trigonometric function called tangent, because it's opposite over adjacent. So what we do know is that we have a tan of 38 degrees, and we have an opposite side of 55 with the adjacent, which we'll call x, which we don't know. So in order to solve this, what we need to do is we need to basically multiply both sides by x. So we're going to multiply both sides by x, and that will leave us with x on both sides. But these x will cancel out. And then, in order to get x by itself, we would have to divide both these sides by tan of 38 degrees. So to get x by itself, we have to divide by tan of 38 degrees both sides. So in this side, there's 55. So when I divide, it'll be 55 over tan of 38 degrees. And you can see that this side, the tans will cancel out, so I'm just left with x. So this is why, because I'm just left with x here, and I have 55 over tan of 38 degrees here. So let's look at how we can actually put this into the calculator then. So basically, what we are doing then is we need to go 55 in our calculator, divide, and then I'm going to open the bracket, and then I'm going to put the degrees, which is 38, and then hit the tan sign, and then close the bracket. Now, because this tan value is under 1, this is going to increase our original value of 55 to something larger, which in this case is 70.3967. So if I were to go back into my actual question here, what I will see is that basically the answer is 70.3968, which rounded to the nearest number is 70 meters, and that's why that would be the correct value for that. So let's take a look at another simple, similar angle of depression type question. So in this particular case, we have, as it says here, the angle of depression from Ed which is here, to the ship is 22 degrees. The height of the cliff is 68 meters above sea level. How far out to the sea is the ship? So once again, this is an angle that's being formed below this horizontal line. But really, once again, it doesn't matter what this question says. If we focus on the actual image, what we can see is that this is the hypotenuse. And this, opposite of the angle we know, is the opposite. And this is the adjacent. And once again, just like the last question, we know the opposite and we want to know the adjacent. So because of that, we are dealing with the tan function. So I'm going to put in tan of 22 degrees, and I would plug in what I know for opposite, which is 68, and then adjacent is what I'm looking for. So once again, I'm going to multiply by the x value on both sides. And then in order to, this will cancel this out, but in order to get the x by itself, I would have to divide both sides by tan of 22 degrees. And that's why when I do this, it will cancel out the tans of 22 each side here. But when I do it over here, I'm going to end up with 68 over tan of 22 degrees. And so therefore, I'm left with just this question here. So if I were to plug this in the calculator once again, what I would get is I would have to take 68 and then divide it by, and then open the bracket, and then put my degree, which was 22, and then hit the tan sign. And once again, it's going to be a decimal value, so it's going to increase this number. I'm going to close my bracket, and then I hit the equal sign. So in this case, it's telling me it's 168.3059. So if I go back over here and take a look, this is why I have this value, 168.3059, which rounded down is 168 meters, which is the answer and is correct. So hopefully that makes sense to you. So let's take a look at two angle of elevation questions now. So once again, this is like the angle of depression, except in this case, this is the horizontal line and the angle is forming above that horizontal line. Now, I'll read out the question. It says the angle of elevation from Ed, this is Ed, to the top of the lighthouse is 27 degrees. The horizontal distance between the lighthouse and Ed, that's this line here, is 22 meters. What is the height of the lighthouse? Now, once again, it doesn't really matter what this question says. If we see what we have here, we can figure out what we know. So this is opposite of the angle we have, which is opposite. This is the hypotenuse, obviously, directly opposite the 90-degree angle. And then this other side is the adjacent. Now, we know the adjacent. And what we want to know is we want to know the opposite. So this is a little bit different. This angle of elevation is looking for the opposite side, whereas the angle of depression in the last two was looking for the adjacent side. So once again, though, we are still working with the tangent function because it's opposite and adjacent. And so we would write down the angle, which is 27 degrees. And then in this case, what we don't know is the opposite. And what we do know is the adjacent. So because we do know the adjacent, all we need to do to get the x by itself is simply multiply both sides by 22, because that would eliminate the division of 22 here. And so what we would do is we would simply multiply by 22 both sides. That will cancel us out, leave x by itself over here. And what I have over here is 22 times tan of 27. So how do I solve that? Well, let's take a look at our calculator. So if I click on our calculator here, clear this off, what I'm going to do is I'm going to simply take the degree of the tan, so 27, and then tan, so that's going to be my value, but then I'm going to multiply by the 22 length there, and that's going to give me a value of 11.2095. So if I once again click back over here, we can take a look at our question. This is why I have the value of 11.2096. And if I round down, so that's why the answer is 11 meters. So looking at this next question, once again, it's an angle of elevation question. So we have this, the question says the angle of elevation from Ed, and that's Ed here, to the eagle here is 25 degrees. The horizontal distance between the two is 159 meters. So what is the altitude of the eagle? So once again, whether we know what the question is, whether we read this, if we have this diagram, we can really solve this without even seeing all this. But what we do know is that we have the opposite side to the angle we know here, which is opposite. We have the direct opposite of from the hypotenuse, or from the right angle, which is the hypotenuse. And then we have the adjacent. And so what we do know is we know the adjacent, and we want to know the opposite. So once again, we are dealing with tangent, and we are going to substitute what we know. So we know the 25 degrees, we know the opposite, which is 159. We want to know, or sorry, we know the adjacent, which is 159. We want to know the opposite. Let me just erase that out because that was the wrong line there. So we want to know the adjacent, or sorry, we know the adjacent and we want to know the opposite. So once again, all we need to do to get rid of this is we need to multiply both sides by this 159 that is currently being divided by on this side. And that's going to eliminate that 159 from that side and leave x by itself. So once again, the opposite of dividing by 159 is multiplying. So this cancels each other out. We're just left with x on this side. And on this side, we have 159 times tan of 25 degrees. So to solve for this now, we just put into our calculator the equation. So we'll start with the angle, 25 degrees, hit the tan button, and then multiply by the 159 side length value. And so we end up with this value of 74.1429. So if we were to go back here, this is why we have this value here, 74.1429, which rounded down in this case would be 74 meters. So hopefully that makes sense to you. Once again, these are practical questions that apply to trigonometry. But if we can draw a diagram like we have here, it is very simple to solve these just like we have before. And just remember this key little thing here. When we are dealing with the angle of depression, we know the opposite and we don't know the adjacent. So that means we have to take the opposite side length and divide it by the tan of the angle that we know. Whereas with the angle of elevation, what we know is the adjacent and we don't know the opposite. So what we need to do is we need to multiply the angle by tan and then multiply it by the adjacent side length to get the value. So hopefully that makes sense to you. Thanks for watching. And once again, as always, if you have any questions, please don't hesitate to email.